Now we are going to see the examples on 11th standard topic, refraction of light. First sum, angle made by incident ray of light with reflecting surface is called. Options are 1. Glancing angle, other angle of incidence, third angle of deviation, fourth angle of refraction. So you know all angle of incidence, deviation and refraction. The only angle left is glancing angle. Glancing angle is the angle made by the incident ray with the reflecting or refracting surface. This was asked in CET 2018. Refractive index of water and glass with respect to air is 1.3 and 1.5 respectively. What will be the refractive index of glass with respect to water? So we know the options are given 1.5 upon 1.3, 1.3 upon 1.5, 1.5 upon 2.6 and 2.6 upon 1.5. Now you are already aware they have given the absolute refractive indices and we have to find out relative refractive index. This is water with respect to air 1.3, glass with respect to air 1.5 given. So glass with respect to water refractive index is written as absolute refractive index of glass upon absolute refractive index of water, that is 1.5 upon 1.3. So the option is A. Let's go to the fourth example. A light of wavelength 6000 angstrom travels from rarer medium to denser medium of refractive index 1.5. If its frequency in rarer medium is 5 into 10 raised to 14 Hertz, then its frequency in the denser medium will be. This was asked in CET 2004. Various options are given. Let me tell you the thing. Frequency does not change though the refraction takes place. Wavelength that changes. So the answer is that whatever the frequency given is 5 into 10 raised to 14 Hertz, it will be the same. So option B is there. Now let's go to the fifth example. If light travels from vacuum to water, its wavelength, obviously vacuum to water means rarer medium to denser medium. Options given are increases, remains constant, decreases, may increase or decrease. So obviously the option is decreases because the velocity decreases, and velocity decreases because the wavelength decreases. Let's go to. So due to limitations of time, we are only going to deal with CET numericals asked in the previous exams. So we will be going to the ninth sum. A ray of light is incident on a glass plate of refractive index 1.5. The angle between the reflected ray and refracted rays is 90 degrees. What is the ratio of wavelength of reflected to refracted rays? CET 2001. Answers given are 2.1, 1.5, 1.6 and none above. See, the interesting thing, the angle between reflected and refracted rays is 90 is given only for making you confused. Wavelength in the same medium, that is air, when it is reflected and refracted ray is not going to change. So answer for the refractive index is wavelength in air upon wavelength in medium is nothing but the refractive index 1.5. So here they have asked wavelength of reflected ray which is equal to incident ray which is in the air medium and reflected ray which is in the other medium. So 1.5 is the answer. Let's go to the 11th sum. A wave of light having frequency 4 into 10 raised to 14 Hertz and speed of light 3 into 10 raised to 8 enters the glass of refractive index 1.5. Find the change in wavelength. That is CET 2002 and 2004. It is 2 times asked. See, here the thing given is the wavelength of light in air. Sorry, the frequency of light in air. It is, frequency is F given 4 into 10 raised to 14 Hertz. And speed is given 3 into 10 raised to 8. So let's find out first from the formula lambda in air is equal to C upon F. So it is 3 into 10 raised to 8 meter per second upon 4 into 10 raised to 14. So the frequency comes to 3 by 4 into 10 raised to 8 minus 14. That is, it is 3 by 4 10 raised to minus 6. So we'll keep it as it is, because now we want change in wavelength. So now mu equal to lambda air upon lambda medium. So 1.5 equal to 3 by 4 into 10 raised to minus 6 upon lambda medium. So lambda medium equal to 3 by 4 upon 1.5 into 10 raised to minus 6. So it is nothing but 1.5. 2s are 2, 2s are. So it is 1/2 into 10 raised to minus 6 meter. So lambda medium, you got it. Okay. Now you have lambda air minus lambda medium equal to change in wavelength. So it is 3 by 4, that we will write it as 0.75 into 10 raised to minus 6 minus half, we will write it as 0.5 into 10 raised to minus 6 meter, which is equal to 0.75 minus 0.550, that is 0.25. So it is 0.25 into 10 raised to minus 6 meter. The option given is here 2.5 into 10 raised to, you have made the numbers bigger, so we have to multiply by the 10 raised to minus 1 will be added, so 10 raised to minus 7 meter. So the option given is A, 2.5 into 10 raised to minus 7. This is the example asked in CET 2007. Light enters from air into medium of Ri, that is refractive index 1.5. Percentage change in its wavelength is. So various options are given. How to find out? Mu is nothing but lambda 1 upon lambda 2. So 1.5 is lambda 1 upon lambda 2. So lambda 2 is lambda 1 upon 1.5. Now change in wavelength is lambda 1 minus lambda 2. Why not lambda 2 minus lambda 1? Because in the medium the wavelength is going to decrease. So lambda 1, that is in air, will be more. So lambda 1 minus lambda 1 upon 1.5. It gives 1.5 lambda 1 after taking LCM minus lambda 1 upon 1.5. That comes to 0.5 upon 1.5. So when you shift the decimal digits, 5 upon 15. So 1 upon 3 into 100% for taking out the percentage, it comes to 33.33% of the original wavelength. The option is C. Example number 13. The velocity of light in glass is 2 into 10 raised to 8 meter per second. If refractive index of the glass with respect to water is 9 upon 8, then velocity of light in water is. So this is asked in CET 2006. So very simple. Velocity in glass is 2 into 10 raised to 8 meter per second. Refractive index of glass with respect to water is equal to 9 upon 8. That is nothing but velocity in water upon velocity in glass. So velocity in water is equal to 9 by 8 into velocity in glass, which is given 2 into 10 raised to 8. So 9 by 8 into 2 into 10 raised to 8 is nothing but 9 by 4. So which is nothing but 2.25 into 10 raised to 8 meter per second. So the option is 2.25 into 10 raised to 8 meter per second. D. This is asked in CT 2004. Ratio of the velocities of light in glass to that of in water is to be found out. So, refractive index of glass is 1.5 and refractive index of water is 1.33. These are absolute refractive indices. So, velocity of glass upon velocity of water is nothing but refractive index of water with respect to glass is nothing but refractive index of water upon refractive index of glass. So, it is 1.33 upon 1.5. Simplifying, you get 13.3 divided by 15, which comes to 0.8866. So last figure is rounded up to 7. So the option is C, 0.8867 is to 1. Let's come to the next example. 16th, refractive index of glass with respect to medium is 4 upon 3. If Vm minus Vg is 6.25 into 10 raised to 7 meter per second, then velocity of light in medium is, this is asked in CT 2005. So let's see, glass with respect to medium is 4 upon 3. So velocity in medium upon velocity in glass is 4 upon 3. So velocity in medium is equal to 4 by 3 into velocity in glass. So Vm minus Vg is given in the example 6.25 into 10 raised to 7 meter per second. 4 upon 3 Vg minus Vg 6.25 into 10 raised to 7 meter per second. So I don't now see whatever right hand. 4 upon 3 minus 1 Vg common, that is 1 upon 3 Vg equal to 6.25 into 10 raised to 7 meter per second. So Vg is 3 into 6.25 into 10 raised to 7. So I kept it as it is. Vm is equal to, already we know Vm 4 by 3 Vg. So 4 by 3 into 3 into 6.25 into 10 raised to 7. So 3 cut. So 6.25 into 4 is 25 into 10 raised to 7 meter per second. So equal to 2.5 into 10 raised to 8 meter per second, which is the option given is 2.5, that is A option.